Welcome to the next installment of my lecture series for managerial economics here at Rutgers University in Camden. And this particular video lecture is going to cover a portion of Chapter 10, Pricing with Market Power. In particular, it's going to go over some of the things you need to know to answer text question 2.2. And the question itself states, if a monopoly faces an inverse demand curve of P equals 200 minus Q, has a constant marginal and average cost of $50, and can perfectly price discriminate, what is its profits? And it's important to realize that when you're reading this, an important part of the information that you need is nested within this question. In particular, the implications of the fact that this firm can perfectly price discriminate. So let's take a look at graphically what that means. Remember that if a firm can perfectly price discriminate, its output level is going to be where price is equal to marginal cost. That is where marginal cost intersects the demand curve. And that will determine what the perfect price discrimination output level would be. So make sure you realize that key component there. It's where price equals marginal cost is going to give us the output level if this firm perfectly price discriminates. And then from that information, we can get what the profits of the firm are, and under this scenario where marginal cost equals average cost, also what the producer surplus is. Realize that the complete area under the triangle, this green area plus this area down here, is going to be total revenue. The bottom portion down here is going to be total cost. So if we subtract that off of total revenue, what is left over is the green area is equal to the profits. So I just wanted to give you graphically a notion of what we're doing mathematically. Some students like to see something and to be able to visualize what they're accomplishing doing something mathematically. So make sure you're comfortable with that. So we know that the inverse demand curve is price is equal to 200 minus Q. And under perfect price discrimination, Q occurs where marginal cost is equal to price, and we know that marginal cost is equal to 50. So if we know that this is the case, we know that price is going to equal 50. So 50 equals 200 minus Q. That gives us a Q of 150. So we know what the quantity is, and we know what the price of that last particular item that is sold by that perfectly price discriminating monopolist. If we go back, we need to calculate this particular area here. So we know what QPPD is. We want to know what the area of this triangle. And the area of this triangle is 1/2 base times the height. The base is just going to be the perfect price discrimination quantity, where price is equal to marginal cost. But we want to know the height of this particular triangle, which means we have to know the maximum price. And then we subtract off the last price that was actually charged in the marketplace. So if we move forward, we know that P is equal to 50, Q is equal to 50, and we want to know what P max is, and that's where Q is equal to 0. So P max equals 200 minus Q, which is 200 minus 0. So P max is equal to 200. So now we have all the pieces of information we need to calculate profit and producer surplus for this particular example. So remember that the profit is going to be that triangle, and it's going to be 1/2 base times the height. And if we place that information in there, we get the height is equal to 150, the quantity is equal to 150. So we end up with 150 squared multiplied by 1/2, and that gives us $11,250. So we know the profit for this monopolist who is engaging in perfect price discrimination. And we know their producer surplus, because they are equivalent to one another in this example. All right, the other portion that comes up is we want to know what's the consumer surplus, the total welfare generated in this marketplace, and the deadweight loss. The consumer surplus and deadweight loss are simple. in a situation where a monopolist engages in perfect price discrimination, consumer surplus is equal to 0 and deadweight loss is equal to 0. And let me give you an explanation for this. The reason why consumer surplus is equal to 0 is, remember what's occurring. Under perfect price discrimination, the monopolist is going to charge the highest price to each individual in that market. So the highest price each individual is willing to pay, the monopolist charges that price. Therefore, no consumers generate consumer surplus. So consumer surplus is equal to 0. The deadweight loss is equal to 0 also, because remember, under perfect price discrimination, price is equal to marginal cost, which is exactly the scenario in perfect competition. And under perfect competition, there is no deadweight loss. It is the most efficient outcome that is possible. So realize that even though this is a monopoly, the monopolist is setting an output at a level that's equivalent to perfect competition, and under perfect competition, there's no deadweight loss. Therefore, the total welfare generated would be the producer surplus plus the consumer surplus. So the producer surplus was $11,250. Consumer surplus is equal to 0. Therefore, the total surplus, or the welfare, is going to be $11,250. Let's change this around now. If a monopoly faces an inverse demand curve of P equals 200 minus Q, has constant marginal and average cost of 50, what is the profit what is the profit, consumer surplus, and deadweight loss? So this monopolist is just setting one price and has an output level associated with that. So it's the classic profit maximization problem that we've done in the past. So realize that output is going to be set where marginal cost is equal to marginal revenue. To get marginal revenue, we're going to have total revenue. So we know that total revenue is P times Q. We know that P is equal to 200 minus Q. So if we have P times Q, it's going to be 200 minus Q multiplied by Q. We multiply that through and get 200Q minus Q squared. And we take the derivative of total revenue, and that gives us marginal revenue, which is 200 minus 2Q. So that gives us the marginal revenue that we need. So let's take a look at this graphically. It's going to be where marginal cost intersects marginal revenue. We go straight down. That gives us the profit maximizing output level. We go straight up to the demand curve, and that gives us the profit maximizing price. And if we want to know what the profits are, it's that rectangle right there. This entire area here, the green and the white in the bottom, would be total revenue. Total cost would be the white area down the bottom that we're subtracting out. And what's left over would give us the profits. Also, we can visualize what we're going to be calculating when we calculate consumer surplus. We're going to be calculating the area of this triangle. So as long as we know what the profit maximizing output level is, what the highest price that individuals are willing to pay, and what the profit maximizing price is, we can calculate that. And what's going to be left over is the deadweight loss, and we'll be able to calculate that also. So we know that marginal revenue is 200 minus 2Q. We know that marginal cost is equal to 50, and that profit maximization occurs where marginal cost is equal to marginal revenue. So if we set marginal cost and marginal revenue equal to one another, we get 500 equals 200 minus 2Q. We rearrange that, so 2Q is equal to 200 minus 500. 2Q is equal to 150. Therefore, Q is equal to 75. We had our inverse demand curve, or function, where P is equal to 200 minus Q. We know what Q is. We can place that into the inverse demand function. We get P is equal to 200 minus 75, and the price is equal to 125. So we know price and quantity, so we can calculate total revenue and total cost. Total revenue is going to be P times Q. So we take P and Q and multiply them together, and total revenue is going to be equal to 9,375. Total cost is going to be equal to average cost minus Q. I'm sorry, not minus Q, but multiplied by Q. So average cost was equal to 50, output was equal to 75. We multiply those together, we get total cost of $3,750. We know that profit is equal to total revenue minus total cost. So we just take total revenue and subtract total cost from it, and we get a profit of $5,625, which is also going to be the producer surplus in this particular example. So we calculated that here. We have that. Now we want to calculate what consumer surplus is equal to. So we know what price and quantity are equal to, and again, we know the price maximum has not changed. So the consumer surplus is going to be equal to 1/2 base times the height. All right, the base is going to be equal to 75, and the height is going to be equal to 200 minus 125, which is 75. We multiply that through, and we get a consumer surplus of $2,812.50. So we already know that the profit and producer surplus for this particular monopolist is going to be $5,625. We want to know what the consumer surplus is. It's $2,812.50. We want to know what the deadweight loss is. Well, the deadweight loss is going to be the producer and consumer surplus that no longer exists when we are not producing at the perfectly competitive level. And remember that when the monopolist engaged in perfect price discrimination, the total welfare level in that scenario was the efficient welfare level, because the perfectly price discriminating monopolist was producing at the perfectly competitive output level, where price is equal to marginal cost. So this market would be operating efficiently if total welfare was equal to $11,250. So in order to determine what the deadweight loss is, we could take that efficient level, subtract off the actual producer and consumer surplus, and that would give us the deadweight loss under the scenario where the monopolist is maximizing profits, is just setting output based upon one price and not engaging in price discrimination. So we know the numbers of the efficient welfare level here, the level of producer surplus and the level of consumer surplus. We subtract those away, and we get that the deadweight loss when the monopolist only sells the product at one price, the deadweight loss is $2,812.50.